You may recall that in the last video I had a lot of trouble with this volume control, and I've been trying to clean it by just spraying deoxit into the, this is the deoxit D5, spraying it into the opening there. It doesn't seem to be doing a lot of good, and I suspect it may be that the carbon element in that one is worn out. The volume control in the other SX62A works fine, but this one doesn't. So I may wind up having to replace that control. But before I do that, I'm going to take it out, take it apart, and see if I can clean it. If I can't, then I'll replace it. But there's actually an upside to this, and that is that that will also allow me to show you how you remove the front panel and so on from these receivers. So let me set up to do that, and we'll take that control out and see if we can clean it up. Okay, now I've tilted it down, and the first step, of course, to doing this is to remove these knobs. Now I've also kind of brushed them off. I noticed there's something that has adhered to this knob, so I'll work on that with maybe some lacquer thinner or something, alcohol, see if I can get that off as well. But this is an opportunity for me to remove the whole front panel, starting with removing the knobs. Okay, I eventually got the knobs off, but a couple of things rather interesting. One is the set screws on these knobs are a complete mix. In other words, some are flat blades like this, some are the spline key that are the original original Hallicrafters, and some are just a straight hex like this one. In other words, an Allen key. Another thing I noticed, let me zoom in on this one. You notice that that shaft appears to be quite different from the others. Now that may be some kind of plating on there, but I think what it is, this appears to be a plastic shaft. And so I think this volume control has been replaced in the past. And if so, then I certainly won't feel bad about replacing it again, because it certainly is scratchy, and there's some other possible issues that I'll need to get to inside the receiver, because one of the problems with these volume controls in the old days was if you put a lot of voltage on them, like the B plus from a tube, the B plus would erode the wiper over time. And so good design was to put a capacitor in series with the B plus before you fed it into the potentiometer, the volume control. But if that capacitor shorts for some reason, then you wind up with the same old problem, that is B plus on the volume control. You won't notice it in the sense of the receiver will still work the same, but man, they will wear out really fast, and I think that may be what's gone wrong here. In other words, I think what's happened is the capacitor inside has been shorted, and somebody, not realizing that, replaced the volume control when it wore out, and without replacing the capacitor, they basically shortened the life of the new one, so it's worn out too. Anyway, we'll get to that later. Next step is to remove the nuts from these controls here and this headphone jack. So let me get to that. And the next step is to remove these screws. There should be 4 of them on the 2 on each side. So I'll do that now. I probably should have mentioned that when you're taking this panel off, you want it to actually be off the edge of the bench like this, so that the chassis right down here is sitting on the bench, because this panel hangs a little below it. So I think that'll be obvious to most people, but just in case, what you don't want is to have the pressure on the bottom of this panel holding against these screws, because then as you take them out, they will tend to burr in the socket, and also when you get the last screw out, the chassis will drop a 1/8 of an inch or a 1/4 of an inch or something like that. So anyway, just good practice to make sure you always have the front panel off the bench so that the chassis is supporting itself. And now the panel comes away from the rear panel, and here you can see what I was talking about in an earlier episode about how this panel, this glass panel, fits behind. And you'll notice that there is a glass panel here which is the front of the receiver, and that's the thing that I'm going to have to manufacture. Actually, I have a piece of glass that I've already cut to this size. I'm hoping it will fit in the other receiver. This one had the front glass, the other one, you remember, did not. And now that I've taken off the foot panel, I have reinstalled it, partly so that I could put these little trim washers on. I got these at, I think, at Ace Hardware. They're generally available. They're used in a lot of other applications besides radios. But I thought I might show you a different way to also remove this control if you have the right tool. Now, when I say the right tool, what you need is a nut driver. It has to be the right size. In this one is a 3/16, or it's called a 37/16. Let's see what it says. Oh, it's a 1/2 inch. It's a 1/2 inch. It also has to have thin walls, and it also has to have a hollow center. Now, a lot of nut drivers don't have the hollow center. The reason you need that is otherwise when you go to put this on, it'll stop at about that point. If you have the right kind, and this set, this is actually one out of a set that I bought from Crescent some time ago. Don't actually remember where I got it or what it cost, but they're fairly readily available. Just make sure that you have at least one of the 1/2 inch size, and then you just undo the nut. Now, as I say, this will only work if you have the right tool. So why didn't I do that to begin with? Well, partly because I wanted to show you, as I had said earlier, how to take the front panel off. Partly because if you go to do things like, if you're working on this dial illumination mechanism, or if you're having to restring the dial, you have to take the front panel off to get to a lot of the areas. For example, I'll try to show you from the top here. Down in there, you will see, talking about right down there, where the connections for the dial cord are. And you can't really get to those very easily unless you've taken off the front panel so that you can get to it from the front of the front panel. So I needed to show you how to do this out of completeness, but it's not absolutely necessary to do this to remove these controls. So now I'm going to pull that control out and see if I can take it apart and clean it up, and if not, I will replace it. Now here's something that you run into in refurbishing or restoring old radios. It's not as uncommon as you might think. Turns out, as I was getting ready to replace the capacitor that was connected to the arm of that volume control, let me move this wire out of the way a little bit so you can see better. You may notice that this connection doesn't appear to have any solder on it. That is the little loop, and it turns out it didn't have any. As I was maneuvering to get the old capacitor out, the solder joint that should have been soldered firmly to this to this tab simply fell away. So I replaced it. I suspect that most of the noise that I was hearing was not the volume control itself. It was just that that connection never was soldered. So here's my speculation. We know the volume control has been replaced. My guess is that somebody replaced it perhaps because it was noisy. Then, because they made a bad solder joint, the one they put in was noisy also. Not because the control was bad, but simply because when you don't have a good solder joint, as you move the volume control, the wire rubs gently on the metal, and it makes an intermittent connection, which sounds just like a volume control noise. So I'm going to solder that up, and hopefully that will fix the problem. By the way, I was able to clean the control, and it seems to be in pretty good condition. So let's try that solder and then see where we go from there. I've been looking over this second SX62A, and a few observations. One, none of these changes were made by me. These changes, with the exception of this one capacitor that I put in, which connects to the volume control. The rest of these are part of an obviously earlier restoration, because these are not original parts, and yet they weren't put in by me as part of this restoration. That tells me that this set's been worked on by somebody in the past. There are a couple of problems with the set. One, I think you saw earlier, is that it's awfully noisy. And the second problem is one having to do with the receive standby switch. Now, what I'm going to do is turn the receive standby switch to standby. You notice that the front panel light goes out. That should not happen. But now I'm going to turn up the volume. And you notice that the receiver is still receiving. The receive standby switch is supposed to shut off the B+. I'll show you that on the schematic here in a second. But it's obvious that somebody has rewired this set, or it wouldn't work that way. Now, here is the receive standby switch. It's right here. And you may notice that the receive standby switch comes up to this point, and there is a 0.01 mic capacitor to ground, and then it goes over to an open pin on this power socket. The only two pins that are shorted are these two over here, so that pin should be open. And it goes up to the center tap of the high voltage winding of the transformer. I have disconnected this 0.01 mic just in case something was wrong with it and it might have been shorted. That is this capacitor right here. And yet, it's still, when I switch from receive to standby, the front panel lights change, but the B+ does not disappear. I suspect what has happened is someone has rewired this transformer, and in doing so, they accidentally connected one end of the filament transformer winding, that is the one that runs the panel lights, instead of the center tap of the high voltage winding to this switch. So I'm going to be working on that, and then I'm also going to get started on trying to locate the source of the noise. By the way, the noise is not present in the phono position. It also is not present if I pull out the AM detector tube, which tells me that the source of the noise is somewhere in either the RF or IF sections of the receiver. But we'll get to that in a little bit. Right now, the main thing is to get this transformer wired properly so that the receive standby switch works correctly. And then we'll go from there. Well, I have rewired the send receive, or the receive standby switch there. and I'll show you in a minute on the schematic, it was really pretty badly messed up. And but I did want to show you that what happens when it's fixed. Now I'm going to turn the volume up a little bit here.
Just don't want to let this game get away from him early.
You may notice there's less interference now,
Such a tough ball for the
less
Astros.
noise, but still some.
Get off on the right foot here.
Flip to the standby position, and you notice the lights stay on and the receiver goes essentially dead. Turn it back to receive, and you get
He's set.
now you notice there's still some noise, but actually I'm beginning to think I know what the source of that noise is, and I'm going to leave that until I get to an alignment point. So let me get the schematic out now and show you what it was that was miswired. Okay, so now this is working. I'm going to turn the volume down so I don't have to compete with the Astros announcer there. What was going on is this. You may remember that I showed you that there's a send-receive switch here. Well, for reasons that are completely inexplicable to me, someone had wired this point, that is the wiper of this switch, which we'll talk about in a second, had wired it to this switch up here. In other words, there was a connection from here to there, and then the connection from there to the center tap of the transformer had been disconnected, and instead the center tap of the transformer had been permanently grounded. Why someone would do that, I don't know. Maybe they thought they wanted to turn off the lights, maybe so that they could listen in the dark or whatever. I don't really know what was going on here, but I think it might be an appropriate time for me to get up on the on the lectern and give a little lecture on working on this kind of equipment. First, remember, this can be dangerous. If you don't know what you're doing, you really should consider getting a mentor. Now, by a mentor, I mean someone in your local community who understands radio. Best source I've found are the amateur radio clubs, but there are plenty of others. There's lots of resources on the web. If you write to an organization like the ARRL, that's called the American Radio Relay League, you can find them on the web. If you write to them or email them and say that you're interested in learning radio and you might like to get a ham license, they can give you the names of some people in your neighborhood who understand this stuff and also understand the safety and so on. So both for the standpoint of not making mistakes that frankly could have permanently ruined, if there had been other ways of wiring this such that it could have ruined that transformer, and then this receiver probably could not have been resurrected. But I'm not blaming the person for trying. I'm just saying that if you don't really know what you're doing, don't do it. Not only for the safety aspect, but also because you're going to probably create problems that'll make it very difficult for someone in the future to undo. So find yourself a mentor, and I think you will discover not only that it's a source of great inspiration and information, but who knows, you might have made a lifelong friend. I'm going to kind of wrap this one up at this point. I was going to continue until I had solved that noise problem, but I'm thinking the problem appears to be, by the way, it goes away when you go to the phono position. It also goes away when you remove the AM detector tube and a number of other little troubleshooting techniques that I've learned over the years to isolate this kind of noise. I believe what I've got are bad contacts in that rotary capacitor. I'm talking about this thing right here. And so I'm going to be working on that, but that does require a little bit of disassembly and quite a bit of nitpicking kind of stuff that doesn't really do too well on videos. So I'm going to wrap up this video at this point so I can go ahead and post it. The receiver now does appear to work on all bands, and except for the fact that it's a lot noisier than this first SX62 over here, it does appear to be working. So I'm ready to maybe start doing a little bit of alignment, and in the process hopefully clean up that capacitor. So once again, hope you've enjoyed it, and I hope you'll stay tuned for the next episode in this saga of two SX62As.